there will be a similarity here, how a loop's magnetic field is going to be, and that of a bar magnet. You see that of the bar magnet, where from the north to the south you're having the B field lines. Similar to that, when you have a loop current, you also get a similar magnetic field around. So in that sense, there are two sources for magnetic field, whereas only one source for electric field. For electric field, the source is only charge. Charge is the cause. But for magnetic field, you can either have a permanent magnet, you can have either a permanent magnet, or you can have a current. You can have either current or permanent magnet. Both of these create a magnetic field, right? So let's try intuitively to understand this question. If you have two infinitely long parallel wires carrying currents of equal magnitude, what is the magnetic field due to the two wires at a point midway between the two wires? That means I have two wires here. Then I have this so-called magnetic. These are carrying currents. These are carrying currents, but case A is both the currents are in the same direction, and case B, both the currents are in the opposite direction. For example, here the current I is flowing up, and so is the current I here. Whereas here the current I is flowing up, but here the current I is flowing down. So that's the illustration of the English law. Now, the question is, how do we know what is the magnetic field? Somewhere in between, yeah? Somewhere in between, at a point in between, yeah? So let's take case A. Clearly, there is going to be a magnetic field due to this current, which is going to be, let's say, like this. So anywhere in between, the magnetic field is going to be going in. All to the left of the wire, the magnetic field is going to be coming out, isn't it? So this is the H field, and this is the H field that is going in. Because you take your right hand, thumb in the direction of the current, fingers in the direction of the magnetic field. Now, how about for the current 2? Again, since the directions are still the same, this guy is going to be still the same. But if you see him, this guy is going to be coming out, and here he is going to be going in. Since the direction of the two currents are the same, magnitude of the two currents are the same, so in the middle, they just cancel each other. But what happens when the two current directions are opposite to each other? Here, the situation is same as this guy. Both these are coming out and going in here. Whereas for the current that is going down, this guy, the magnetic field here is going in, coming out, going in. It's going in. So then comes this guy is going to be coming out. So in this case, these two currents will, these two magnetic fields, they will add up. So case A, they cancel. And for case B, they add up.